So actually, I think it's the 17th, just in case I might have some questions. The video didn't compile, so I'll get a similar old kind of lecture I have recorded that kind of goes over. I mean, if you were in class, it doesn't matter as much, but if you weren't, I'll get that up this afternoon. I set to find kind of what would correspond to what we talked about. So the midterm, I will make available as soon as we're done with class on Wednesday. Essentially kind of like a take home, except for once you kind of open or start the file, it'll have like a 2-hour time frame, and you have to upload your kind of responses within those 2 hours, or before that 2-hour time frame is up. These questions are good to study. I would also say the homeworks would be really good to review. And then we won't have class Friday, right? So, and sorry, I think I'm able to say too, after I make it available Wednesday, you can upload it. You could start at any time from Wednesday all the way to the end of the day on Sunday, right? So you've got several days. I'm guessing most of you probably aren't going to do it on the weekend, but just, I know I've had a couple people talk to me about their schedule, and I just want to make sure that is possible. So, go to the homeworks, kind of look at these review problems. We'll kind of start going through some of these, and I'll just throw in some additional things I think might be a good thing to know as well. But it'll look kind of similar to this, where it's got about 10 multiple choice questions. And I think it was, I think I only had 4 short answers that were broken down into parts. Can't remember if I called 2 were really closely related. I can't remember if I threw them together or if I made it like A, B, C, and D, as opposed to just 2 questions with A and B. We'll start kind of chipping away at these. As you start studying, if you have any questions, or even today, I can start out with if there's a specific type of problem or something you want to see work through. I can do that. Otherwise, I'll just kind of pick and choose and go through the ones I think are probably the most relevant. Anything that anyone would want to kind of see started out, or type of problem, or just a question? So I'll go through a couple things I think would just be good to know to start out with. Well, I'll go through the things that we want to think about, the different types of market or different types of models that we have. So the first one, I think the first problem on the midterm practice problems gets at this, is this idea of looking at our ticket market. So if I remember, so this one has what? Team A is currently selling below their capacity. Team A is below its capacity. Team B is selling equal to their capacity. They both increase the size of their stadium. What would happen? So we've got Team A. Now, I think we're also told in that problem they're monopolists. All right, so they're able to single price. They're a single price monopolist, and so you don't really know exactly where demand is going to be, but if they're choosing a point that's below capacity, you for sure know that marginal revenue is going to hit that x-axis, right? Because unless they're selling at capacity, right? If they're selling at capacity, well, that's when you would have that marginal revenue curve hitting, right? That vertical line. So this is Team A, and we could put it on the same graph if we want. So let's think about Team B must have a marginal revenue curve up here because they were selling at capacity. So I'll then draw in their demand curves. So even if this is like a multiple choice, multiple choice question, right? It's always kind of probably useful to like draw something out to kind of lead you to what that correct answer would be. So Team B, their optimal price to begin with is going to be here. Team A chooses, actually, I should probably write these as go with 1. Team A chooses the quantity where marginal revenue hits marginal cost. But remember, with our tickets, the marginal cost is 0. Right? Well, it's more like there's a fixed cost, but there's no marginal cost of selling additional tickets. The seats are already there. So we then go up to our demand curve, and this is where they're going to set their price. So what would a shift in this capacity look like? So we said that, right, here's our new capacity. And now we can think about where our new price and quantity combinations. So for team A, what's going to happen with this new stadium? Nothing, right? They stay at the exact same point. So there's no change for team A. Right? Team B, we still could see them choose to continue to sell. I guess I didn't write this in before, but they could keep quantity the same, but they'd have to lower price, right? But this is where, when we're kind of drawing these models, especially in this ticket market, we need to think about the size of these shifts. If we ever have to draw a shift on our ticket market graph, probably there are some situations where the outcome depends on the size of that shift. So the one I just drew, right, the capacity didn't go up very much, right? And so we were still selling, sorry, what am I doing? Quantity's not the same. I'm moving the capacity line. Sorry. So we're going to sell a higher quantity, right? But set a lower price. Now, it might depend how far out I'm going to go, that the new point might not be where I'm selling the entire capacity. So I can kind of draw this on a separate one. I didn't give myself enough room. So let's imagine we had something like this. Here was my marginal revenue for that team. Here was demand. I then build this new stadium. We'll kind of notice they would still increase quantity. Oh, there we go. Like this was, what's it, team B? So they would still increase quantity, but not by very much. It's just now they're no longer selling out the entire stadium, right? So even if we drew, like, no matter where the marginal revenue curve hit that original capacity line, once we build this new capacity, we're going to see a increase in quantity, right? But we just don't know if we're going to be selling out, right? If I was to ask you a question about, like, after they build the new stadium, are they selling out capacity? And the answer would be, we don't know. It kind of depends on how much larger that new stadium is, right? But we can for sure say they're going to increase quantity a little bit. Right? I guess theoretically, if they were exactly at this point, they would keep the quantity the same as what it was before. But we know that it's not going to be decreasing, right? And then we kind of know the direction of the price changes as well. So I remember this one is asking about revenues and prices. So there's one more thing we could kind of add in. Like some of these multiple choice have like multiple concepts. So that was one concept of just understanding the price quantity changes, right? So we said the price team B charges will decrease, right? So we know it's going to be either this one. Actually, yeah, I guess, never mind. I guess if this was multiple choice, it wouldn't be that interesting. But if I had put some more difficult answers in there, what about ticket revenues? So this is where we can think about all total revenue is from these ticket markets is price times quantity, right? So if we've got that the quantity is remaining the same, price is remaining the same for team A should see no change in total revenue. Now, if I was interested in team B, right, well, their price went down, quantity potentially went up. I've got these things moving in opposite directions. I can't really say, right? I would need to know something about the elasticity of the demand curve. I'm not going to kind of throw back elasticities into the class. So, but here, all we would leave it at is we can't say, uncertain, indeterminate, right? So go back here, should be hopefully the, right? So team B price decreases. I guess here I shouldn't have said remain unchanged. It's not that it remains unchanged, it's that we don't really know which direction total revenue is going to go. I'm trying to think of anything else that would go in here. So one other thing that would be good to know when we're looking at these ticket markets. So we've got capacity movements, but we also have things that move. So let's say we're not selling out. Let me call this demand 1, marginal revenue 1. So we've got, here's our price, here's our quantity. let's say we have a demand increase, right? Something that increases demand. So what's going to happen to our price and quantity? Oh, we see a shift up, right? Oh. My new point is maybe now I am selling out at capacity. So I've got a higher quantity and I also have higher price, right? So that's an easy one. If I'm not selling at capacity, then doesn't matter how I draw the side of the ship. I know that I'm going to see kind of this quantity go up and the price go up as well, right? But let's say I had a different model or a different starting scenario, which is that they were already selling at capacity. So there, they were hitting that capacity curve. So we have kind of their equilibrium quantity, equilibrium price. Probably should have drawn these a little bit not as flat, but I'll get the idea. Now my new quantity is actually going to be at the exact same point, but at a higher price, right? So it kind of depends, like what's the outcome of a demand increase? Well, it depends, right? If I'm not selling out at capacity, this demand increase should push quantity and price both up, right? However, if I'm selling already at capacity, I can't sell any more tickets, right? So if I see a demand increase, I'm going to see that quantity stays the same. I see that the price would go up, right? Which, if quantity stays the same and price goes up, what's happening to total revenue? Going up, right? Now the opposite direction would be kind of where we have to start to think about, well, what's the size of the shift? So let's say instead we're going from 2 to 1, right? Let's say I'm having a demand decrease, right? Well, if I had drawn it like this, yeah, if the demand doesn't decrease by very much, what happens to my price and quantity? Well, quantity could stay the same and price would go down. But if I saw a really large shift in demand, call this 3, it could be that I see both price and quantity go down, right? So there it kind of matters the size of the shift. So when you're drawing these demand shifts, or kind of these capacity increases or decreases, it's helpful to draw something. It's helpful to draw a picture, even if it's just a multiple choice question. But think about the size of the shifts often kind of could lead to 2 different scenarios. Okay. Any questions on anything there? Change something else? It's kind of more of a general overview. These are all these outcomes are things that I could phrase questions to be like, let's assume you start out, your team currently isn't selling out, you see a demand increase, or you currently are selling out the stadium and you see that they decrease capacity, right? All these different, a lot of different combinations, right? But capacity increases, decreases for teams that are either currently selling out or not selling at capacity, and then also demand increases or decreases as well. All of that could be fair game. Okay. Questions on that? Does that make sense? Okay. So it's another one I wanted to make sure we cover. Oh, I want to go back through and do a little bit of revenue sharing. So which of the following, if you had equal revenue sharing, so this would be kind of every team pays the same percent, you then give the money back out to the teams, which one would improve competitive balance the most? So we've got these different combinations of win and profit maximizing. So what is this going to look like? And I'll maybe phrase the questions, some other questions a little bit differently here as well, because I know the one that I wrote that looks like this. So let's say we're thinking about revenue sharing, teams that are win versus profit maximizing. So we should be looking at kind of this wins as our quantity, right? The number of targeted wins. I'll always, and I'll try to be more explicit on the exam than I was, all right? Well, I've written it. So I'm more explicit on the exam than I was in these practice problems. But I'll tell you things like, hopefully we remember, but I'll give you a very, like, in these models, they're not complicated, make it a little easier. We're just going to assume we have constant marginal cost to a win, right? So if we got constant marginal cost to a win, and we have actually, let me match up with this problem because I don't think I said anything about. Okay, so we got large and small market teams in this example. Let's say got my small market team, and I've got my large market team. I'm just going to draw them pretty far apart here. So if I have a revenue sharing program and I take a percent of income, what's going to happen to these demand and marginal revenue curves? So if I take 50%, they should decrease, shift to the left, right? I'm keeping half of every dollar I was making before. So the incentives are about cut in half. Let's just assume 50% just to have a number to say. However, if it's a percentage-based revenue sharing scheme, what's going to be true about the shift in the demand and marginal revenue curves for the large market versus the small? Well, for the large market, it's actually going to be a bigger shift, right? Because they're starting out with a higher level of revenue. Up, 50% of 100 million is a lot more than 50% of 10 million, right? And so I'm going to see a larger shift kind of in this large market team's marginal revenue and demand curve. So I know that is going to bring these points closer together, regardless of what type of, profit versus win maximizing behavior they're going to have. So let's assume that, how do I want to show you this? So we've got both these shifts. I guess I can do it all in the same graph. It just becomes a lot if you don't have colors. So, maybe the shift for the small market team looks something like that. And we get kind of this large market team, kind of their new marginal revenue curve. Going to be a much larger shift. I try to kind of draw this proportion, right? So I can think about, well, if they're both profit maximizing, right, the previous number of targeted wins we're at these points where marginal revenue hit marginal cost. The new maximizing point after the revenue sharing, if they were profit maximizing, call this 2. I tried to draw so you can kind of see that reduction in targeted wins was much larger for the large market, right? If they're kind of targeted wins, it fell by a lot more than what the small market is. Now, this is if they were profit maximizing. We know that this is going to be the case, right? So the new difference would be, there we go. Getting all my subscripts. Oh, not on the screen. Getting my subscripts right there. Right? Now, the reason why it doesn't matter, I didn't draw the average total revenue curves in. That doesn't matter for profit maximizing. Why? Because if I'm profit maximizing, still going to be where marginal revenue hits marginal cost, right? Now, if I'm win maximizing, I can think about before. So we'll call this win maximizing 1 for the small market team, and then we would have had win maximizing 1 for the large market teams. So I saw this reduction because they pay all this money in, but the league then gives them money back, right? So I now have this kind of, I should now have an average total revenue curve for both teams that looks something like this, where it's kind of getting closer to that demand curve as we see a higher number of targeted wins. So if they're win maximizing, the new point would be somewhere over here. Yes, I know there's a lot kind of going on here. And kind of the new win maximizing point for the small market teams would be out there where the average total revenue curve hits that marginal cost curve. Now, when it comes to the exam, I'm not going to have this many things going on there for you. I like really single things out. So what I might do is something like, let's assume that we start out, I probably wouldn't do like a large and small market and then ask you about revenue sharing. This is just saying like combining multiple things that you would want to know how to be able to identify. So here I've taken large and small markets. I've also done kind of a revenue sharing example. I probably on the exam will break this down more into 2 questions where you're just going to look at, well, what's the effect on just one type of team of this revenue sharing program? And then maybe what are the differences in large markets, small markets without revenue sharing, right? I'm not going to combine them to make them as complicated as this, but this is a comprehensive view of it all, right? But hopefully we can see here, like if they're profit maximizing, it should be that there's a reduction, and then also if they're both win maximizing, we see a reduction as well. Now, if one of them is profit maximizing and the other is win maximizing, it's actually possible that, right, that gap actually could grow, right? Because if there's profit maximizing, I'm pushing the small market team down. And yeah, the large market will see a reduction in wins, but I don't know, without any other information, I don't know if that reduction will be as much as what the small market team has. So if we ever have the large market team win maximizing, small market team profit maximizing, we don't really know if we've actually improved competitive balance without additional information, right? Now, if they're both profit maximizing, we for sure know that we've seen this reduction, right? And that was a byproduct of the fact that the large market was seeing a larger shift or a larger decrease in their demand and marginal revenue curves. So I think there, the thing about what combination should be when they are both profit maximizing, right? Because we know we're going to see kind of the greatest reduction. Actually, sorry, not true. Because what would be the largest one? So profit maximizing would be the second. What's actually even better? How can I make sure that I'm getting even closer?
When the smaller team is win maximizing.
Yeah. So what I would want is for the large market teams to be profit maximizing, because where is this at? Right here. That's the lowest number of possible wins for that large market team. But if I'm trying to improve competitive balance, I'm trying to get the small market team to as high of a point as I possibly can. The highest possible wins that we had for the small market team was when they're win maximizing. Right? So if I have this revenue sharing program, the one that actually leads to the most improved competitive balance, large market team profit maximizing, small market team win maximizing. Second would be full profit. Questions? I know there's a lot going on here. So I might do something a little bit different. So I might ask you something more like this. Let's assume got a similar setup where we've got constant marginal costs, right? And I might do something like, okay, assume that you've got all equally sized teams, like you've got no small, no large market teams, right? This could be maybe kind of a weird one, but let's assume that we've got this team, and there's the league institutes a type of revenue sharing, right? This is, I don't know if we explicitly went over this, but things we've talked about, you could piece this together. So if I have a revenue sharing program, what's going to happen to this demand and marginal revenue curve? We're going to see it decrease, right? So before I go on, I'm going to go, here was my original profit maximizing number of wins. Here was my original, win maximizing number of wins. Right? So I'm going to draw a decrease here in my demand and marginal revenue curves. So we'll call these 2. My new point for profit maximizing would be here. Right? Where would my new point for my win maximizing? So this is kind of weird, but I know that I actually can tell you exactly where it should be at, right? And I think I do this a little, not quite, probably to scale. But if I have equally sized teams, we all pay the same percentage of our revenue. If we were all profit or win maximizing, we're having the same behavior, what should be true about every team? They all would pay in exactly what they would get back if they're all equally sized teams, right? And so we would actually know that the point at where average total revenue is going to hit that marginal cost curve would actually still be at that same number of wins as before, right? Because whatever I'm paying in, I'm getting the exact same amount back, right? So I might use something like that where I kind of assume there's no differences. That way, you know where this average total revenue curve is going to go. And if that was the example, if that was the case, they actually would target the exact same number of wins as before. Does that make sense why that's the same plan? We could go through like the math. I mean, you're paying in, $10 million. Everybody pays in $10 million because we're all the same size. We then all get $10 million back, right? Now, it's still going to be different if I'm profit maximizing because I'm just giving that $10 million either way. So I might just pocket it if I'm profit maximizing, right? But if I'm win maximizing, then I'll just end up spending I'll have the exact same amount of money that I had before. So I'm going to spend up to the point where profits are zero. It should be the exact same point. Excuse me. Questions on that one? So I don't know if we explicitly went through something like that, but kind of trying to simplify some of this down to where we would know exactly where that average total revenue curve hits the marginal cost curve. Kind of did like salary minimums and maximums on Friday. I think I'll leave this for now. But one other one that I wanted to cover, just because I know that there isn't as much on there wasn't one on the homework set. Now I need to find it. Where is this at? Here we go. Number 7, right? So we had this discussion of externalities, right? And we want to think about if we've got externalities existing, what we want to compare the optimal point for society to the optimal point for whatever that free market is. So here I've got one. I said the positive externalities that exist are greater than the next negative externalities that exist to a city, right? What is true about the current number of games that the team decides to play relative to the socially optimal point, right? So the way that we want to look at these externality models, and here you could draw both shifts. I mean, you could draw, both types of externalities, positive and negative. But if I know that the positive externalities are greater, I don't really have to draw both shifts, right? All I have to draw is kind of the one that's going to kind of win out. But I'll draw both of them just to kind of make the point. So let's say we've got my supply curve, got my demand curve, reflecting the private costs and private benefits in this market. I'm then going to have my positive externalities existing, right? What's that going to do? So here, just like when we have two shifts, I'm going to write out the impact of each one. So I started out with no externalities, right? Or I guess I started out, but with no externalities, we're going to think about, we'll call this perfectly competitive. This is where the market gets to, right? Where supply is equal to demand. So that positive externality tells me, well, the point that society would like is actually higher, right? So you kind of think about, we actually want, with a positive externality, the desired quantity is actually higher than what the market gets to, right? Now you can say either way, right? We want the quantity to be higher or it's currently too low, right? Either way. If we then think about it, I also have this negative externality that exists, but I was told the positive externality is larger. So we think about what would a negative externality do? Well, negative externalities add in additional costs. So if we're adding additional costs, it's kind of like we're getting a decrease in our supply curve, right? The actual supply curve isn't shifting, but if society can make their decision, and I'll draw this kind of pretty small because I said that the negative effect is larger, so I can kind of show you this. Or sorry, I think I said the positive effect was larger in the problem. So here's my marginal social cost. Now, if it was just up to that, so let's say we just had the negative externalities. Negative externalities actually kind of show us that I don't know why I wrote S here, but negative externalities actually mean that we want the quantity to go down, right? That currently the quantity is too high. But we had both of these going on at the same time, right? So the one that's going to win out is the one that is a larger effect, which was the positive externality, right? So in this model, if I told you you had both externalities existing, but that the positive externality is larger, well, you know then that our quantity that society would want is going to be higher than what the market currently gets to, right? Now, if the negative externality was larger, and I had like a really large shift over here, so with both externalities, my actual equilibrium would be here, right, for society, where marginal social cost equals marginal social benefits. If I had a larger negative externality, you can kind of see my point here, then we would actually want a lower quantity for society, or that would be the effect that kind of wins out. Right? So I probably won't throw both at you at the same time. Probably be a little more easy than that. But you should know that when we have positive externalities, society is going to want a quantity that's higher than what the market gets to. When you have negative externalities, society is going to want a quantity that's lower than what the market gets to. Right? But if you had both of them simultaneous, you actually, you could kind of draw that out as well. Right? So what's one way? We said we think about this as like the number of games we've been playing a city or something like that. What's something that the city might want to do if they believe there are positive externalities that exist that are greater than the negative externalities? Well, they know then the market would arrive at a quantity that's too low. So how can I try to increase the quantity? So what do these cities do for teams? They give them, they give them money, right, to build the stadium. Essentially, you can think about it as whatever the team's marginal benefit was before to supply, to get in, they've just increased it, right? And they're just pushing that demand curve closer to that marginal social benefit curve, right? Questions on this before we keep going? So I think in that one, right, we get that there are fewer games than socially optimal, right? We said we want the quantity to be higher, so that currently would be too low. Yeah, we went through one kind of like this. I don't think the game theory is too bad. Let's go over something like this because I noticed this in the homework. Another model that you asked questions on, as we were thinking about, was kind of that reserve clause and kind of understanding the difference of monopoly versus monopsony power, unions, kind of exhibiting monopoly power in the player wage market, and then monopsonies kind of being when the teams have rights to the player, and the only way they can have a different team is if they trade them. So, what did those models look like? We had our labor market. So we had the quantity of labor and wages. So we could think about this as got some supply curve for labor, and I've got some demand curve for labor. Right? If I have monopsony power, right? I know that there's only one employer. I know that those teams will make the wage setting decision by doing what? Using a twice as steep marginal expenditure curve, right? So just like with monopolies, we kind of have this twice as steep marginal revenue curve, which is twice as steep as demand. Well, that was when we had one seller of the product. Monopsony, there's only one employer or one person demanding that product. We're going to have a marginal expenditure curve twice as steep as supply. Right? So we think about with the monopsony, we're going to have, this is our equilibrium quantity compared to if this was a perfectly competitive market, right? So this is kind of like with the reserve clause, without the reserve clause, right? The wage for the perfectly competitive market would be wherever, supply and demand intersect. And then the wage for the monopsony, so think about this way. If the teams are the only one consuming labor, then it should lead to them getting a more favorable outcome. So for the teams, what would they like to do? Pay players more or less? Less. So if instead of accidentally thinking, oh, the wage should be up here and the monopsony would hire wage, well, no, let's think about what this even means, right? Being a monopsony is actually a good thing for you if you're the monopsonist, right? It's not good for, we got some deadweight loss going on. It's not good for the players. And so what ends up happening is actually this is our equilibrium quantity, but we know that players are going to be willing to willing to play for wherever they're at in their supply curve. So we see that the monopsonist kind of leads to this lower wage, right? Any questions on this? Another kind of thing that I could throw out there because we calculated a few of them. I really want to try to hammer this idea home. That we can do this in any of these models, especially after the exam, we'll start dealing a lot more with like these labor markets. Where would my consumer and producer surplus be here? So we looked at this kind of in the ticket market, but you can do the same kind of thing here. So we said consumer surplus is the area that is under my demand curve, but usually we would say it's above the price I'm paying. Well, the price that's being paid now is whatever the wage is. So my consumer surplus is actually this entire area, right? The area under my demand curve, but above the price I'm paying, right? So this is the this is with the monopsony power, right? So you got pretty large consumer surplus. Remember, we're dealing with the labor market, so the consumers are actually teams, right? It was good for them to be a monopsonist, right? They didn't want to let it go. For the players, the suppliers of labor, where's the producer surplus going to be? Well, that's whatever their benefit is, their wage, right? How much they're being paid, the area below that, but above their marginal costs, right? Or, kind of remember, think about demand shows us marginal benefits, supply kind of reflects marginal costs. So we've got the area under the price they're getting paid, which is their wage here, but above my supply curve. You can see here with the monopsony power, producer surplus is quite a bit small. Right? If we lift this reserve clause that we no longer have monopsony power, won't draw it on this graph just because it gets a little bit, it's too many colors and things on. What's going to happen to producer surplus if I lift this reserve clause? It's for sure going to go up because it's now going to go back to the perfectly competitive wage. This is my consumer surplus, right? What's going to happen to producer surplus? We need a little bit more information, but it's likely probably going to go down as long as, right, because the new producer surplus is going to be, the new consumer surplus is going to be this entire triangle here. So, they gain this, but lose this, and you kind of visually see it's likely that they're going to lose out a lot more by not having that monopsony power than they would gain there. In fact, with linear demand curves, you can actually probably mathematically show that that's going to be the case. So if we reserve this, if we lifted this reserve clause, we should see consumer surplus actually going down, producer surplus going up. But remember here, our producers are the players, right? So they like, you're a player, you would obviously want that reserve clause lifted. But just thinking about kind of identifying surplus in this model. Okay. Questions on this before we keep thinking? Do one more thing. So let's say we do have some union power. So I have my supply curve, demand curve for labor, quantity of labor, wage. We'll identify where we would be at if this is a perfectly competitive market, right? So now if instead of monopsony power, if we get the players to kind of come together and kind of form a union, right? Have a players union, what's that going to do to this market? Well, the players are the suppliers of labor. So if they're the only supplier of labor is from the players union, they now have monopoly power, right? There's only one supplier of labor if they unionize. So we've got this twice as steep marginal revenue curve that they'll be making decisions based off, right? So where would be kind of the new equilibrium points? Well, they're going to make a decision where marginal revenue hits marginal costs, right? So the monopolist, right? We're going to see a reduction in labor here. But they know that they can get away with charging, or kind of teams will pay a much higher wage, right? Wherever we're at on that demand curve. Same kind of idea. If I've got a players union, what should that do to wages? Well, unions, the whole purpose is to increase the wages. So if you accidentally identified this as the wage, and you're like, oh, wages go down. Wait, I'm thinking about a union. That doesn't make any sense at all, right? So we've got kind of higher wages now for the players. So if we wanted to use surplus in this model, what would kind of a union do? Well, my new, I think, what did I color green? Okay. My new consumer surplus, the area under my demand curve, but above the price they're paying or above the wage that they have to pay, is up here. And then my producer surplus is going to be the area under the price that they're paying or the wage, but above their supply curve, right? So what's happened to consumer surplus if the players are able to unionize? Well, once again, I won't draw it there, but hopefully we're kind of familiar with the regular market surplus, where that would be my entire consumer surplus of that entire large triangle. So consumer surplus goes down when I have the union. Looks like producer surplus, once again, lose out on more than I gain. So actually we see kind of, if we didn't have a union, we would see kind of lower surplus, right? So the union actually increases producer surplus, decreases consumer surplus. Which, once again, producers are the players, right? The union increases producer surplus. That's what they want. So thinking about where those surplus areas would be a good thing to know when we're thinking about just these union and monopsony models. Any questions on this? Just a little bit of just kind of going through some general models as opposed to specific questions today. I'll try to do a little bit more of like, let's go through these questions on Wednesday. But I just want to kind of revisit a lot of these models that you should be able to kind of give me a depiction of or a graph of. Okay? I'll also mention for sure you'll have some game theory stuff on there. So let's just go through one real quick because I think it's just worth kind of getting some review on. So I actually would set it up something like this, right? Where I tell you kind of maybe not explicitly kind of what their payoffs are. You might have to do a little bit of calculation, right? So here I've got team spending. So they're spending the same, they can either spend 5 million, and then if they both are spending 5 million, you have the corresponding revenues of 10 million. You also are told if they spend additional 2.5, right? Then they'll see their revenues go up by 5 million. And then kind of the different combinations down here. So we'll start writing this out, right? So we've got their decision to either spend $5 million or an additional 2.5. So we can kind of think about maybe like a total of 7.5 million. So what did I do here? Oh, there we go. I said, where's my Zoom thing? So we've got two teams. We'll call this team A, team B. They can spend 5 million or an additional 2.5. 7.5. If they're both spending 5 million, I believe the problem said they'll get $10 million in additional revenue. So if I wrote in the revenues here, why is that not the total payoff? Because I also have these costs, right? So the total payoff to these teams or their profits should be whatever that revenue is minus the costs, right? And you could think about this here. And actually what I'm really doing in this problem is I'm looking at marginal profits because I'm telling you they're spending an additional 5 or an additional 7.5. And this is the additional revenue that's generated. So the same sort of principle would apply though. You still want to know, well, what's going to be changing profit the most, right? If it changes revenue the most, but it also changes costs even greater, well, then it's not a better choice, right? So we'll go through each one and kind of calculate these payoffs. So for the 5 million, and they're both spending that, they earn $10 million in revenue. So there, what would their additional profits be? Got 10 million in revenue. They had to spend an additional 5 million to get that. Oh, I forgot to put the M on there, but 5 million each. Right? And then go back because I don't remember the other numbers. If they both spend the additional 2.5, so a total of 7.5 million, then they raise their revenues by 5 million each. Right? So here, if we both spend the additional 7.5, we've increased our revenues by 5 million. I'd actually be worse off here. All right. I made an additional 5, but I had to spend 7.5 million to get it. And then the different combinations of these two things. So the team who doesn't change their spending. Oh, wait, did I read this wrong? Yeah, I read this really wrong. Sorry. This was for a different one. If they both spend the additional 2.5, there's no change in revenue, right? So in fact, I shouldn't have negative 2.5 here. I should actually have negative 7.5, right? Sorry about that. So the other combination was when, if one team spends the additional money, they see their revenues increase by an additional 5 million. But the team that doesn't would lose 3 million, right? So kind of think about it here as, if I'm the team that spends the additional money, right, then I get that additional 5 million. So I'd have, I show this to you. So I'd have 15 million total. I had to spend 7.5. So I get 7.5 million. Team B didn't spend the additional money. They lost 3 million of their $10 million in revenue. So they have 7 million, kind of minus their cost of 5. They only get $2 million, right? And then we have the reverse here. And that's how we kind of come up with those payoffs, right? Probably would be a little bit kinder on the exam, and not thinking about, I would probably phrase this as like spending 0 versus something else, so that it makes it a little bit easier to calculate some of those payoffs for these guys. So I probably wouldn't do like 2 different amounts here. I would probably do like, they don't spend any additional money, they spend this amount. But once we have the payoffs in, hopefully these game theory ones are pretty easy to solve, right? We would just go through, kind of think about, if team B is spending 5 million, what's optimal for team A to do? Down here. Actually, I'll use a different color. If team B is spending the additional money, what should I do? Should definitely 2 million is greater than negative 7.5. Yeah. So it should be, they both spent 7.5 million. They get, oh, sorry, no, you're right. Someone should have called me on this. What should this be? 2.5. Yeah. Sorry, I was thinking about this number's wrong. I forgot the original $10 million of revenue. So this should be 2.5. So I actually should be where? Down here. Thank you for pointing out. I was gonna say, I forgot the original 10 million factoring in there. And then we go through the same thing since it's like symmetric. If team A spends 5 million, what does team B do? Over here, team A spends the additional money. What should team B do? Once again, 2.5 is greater than 2. So we actually end up with a scenario where they're both spending additional money, but earning far lower revenues than if they can kind of come to an agreement and both not spend the additional money. Right? So it's kind of like the idea of like an arms race, right? Or a spending war. There's always to be an incentive to one that always going to be an incentive to be the one who spends more. And as a result, that kind of pushes us down to this prisoner's dilemma equilibrium. Sorry, and just to clarify, since I made that error, sorry about that. So they're both spending an additional 7.5, but they didn't get any additional revenue, but they still have their original 10 million. So that's where that 2.5 was coming from. So I will actually not be in my office hours today, but I'm just going to move them to tomorrow. So 2 to 4 tomorrow, 2 to 4 Wednesday. I'll be around Thursday from 2 to 4 if you have questions as well as you're kind of studying, kind of preparing for that exam. We'll just go through more questions on Wednesday. Like I said, I'll probably do a little bit less kind of broad, general, more specific to those questions on that practice exam Or I might even touch on some old homework questions if I think that those would be beneficial, okay? All right, I will see you guys, actually, before everybody gets out of here, since there's a lot of people here, and I'm also kind of interested. Make sure I have the right class started. Just respond with any letter on your way out for the iClicker question. Everybody will get the full kind of 10 out of 10 for the day. There we go.